Hey everyone, welcome to Hexagon Digital Services. Let's take a quick tour of what we're going to build. The game offers two exciting modes, player versus player and player versus AI. Whether you're playing with a friend or testing your skills against the computer, this Tic Tac Toe game has got you covered. First, let's try out the player versus player mode, where two players take turns on the same device. Now, let's switch to the player versus AI mode and see how the game responds when you play against the computer. It's not just about creating a game. You learn how to write clean, maintainable code by following the try, don't repeat yourself, principle and structuring your project using a feature-first folder structure. This helps in organizing your models, screens, utilities, and widgets clearly for better scalability and team collaboration. Let's dive in. Start by creating a new Flutter project. Let's name it tic_tac_toe_game. When prompted, select the platforms you want to build for. In our case, we'll target Android, iOS, and web to make the game cross-platform and accessible on all major devices. Let's clean up the boilerplate and remove any unnecessary code to keep our project neat and efficient. Let's select the emulator where we'll test our Flutter project. You can choose from available devices like an Android emulator, an iOS simulator, or even Chrome for web testing, depending on your setup. Create a new file, main screen. Now, let's import the material.dart package. You might have noticed that as I started typing, Android Studio automatically suggested the correct import. To enable these helpful suggestions, make sure code completion and auto-import settings are enabled in your IDE preferences. This will speed up your development and reduce the chances of errors. Now, call your main screen class inside main.dart and pass it to the home attribute of the Material app widget. Run the app by clicking this green icon. It may take some time, since the speed of Android Studio depends on the laptop's configuration. As you can see, there's a debug banner on the top right corner. Let's remove it. In the Material app widget, there's a property called Debug Show Checked Mode banner. By setting it to false, we can remove the debug banner that appears in the top right corner during development. This helps give your app a cleaner look while testing. Let's change the title to Tic Tac Toe Flutter Game. Now let's move to main screen file. Replace this placeholder with a scaffold. In Flutter, a scaffold is a basic layout structure that provides a default visual framework to build your app's UI. In the body of the screen, we use a container widget. This container has a decoration property with a box decoration. Inside the box decoration, we add a beautiful linear gradient that starts from the top left corner and fades smoothly to the bottom right corner. The colors blend from a deep blue shade to black, giving the background a stylish and modern look. Here's the output. Inside the body, we wrap everything the center widget to align the content in the middle of the screen. Then, we use a single child scroll view to make sure our content is scrollable on smaller devices. This helps prevent overflow issues. We also add some padding around the content for spacing. Inside this scroll view, we have a column widget that vertically arranges all the child elements. It's centered using main axis alignment.center, making the layout feel balanced. We start with a bit of spacing using sized box. Then comes a hero widget with the tag logo. This allows us to create smooth transitions between screens using a shared element. Inside the hero, a stylized text widget that displays Ultimate Tic Tac Toe. The backward slash n here is used to break the text into a new line. As the text is not clearly visible, let's style it. Now let's style the title. Before that, let's refactor the code using Dart format option in Android Studio. Let's make this title look amazing. First, we center the text using text align.center. So it sits perfectly in the middle of the screen, clean and balanced. Now comes the styling magic. We crank up the font size to 42, big, bold, and eye-catching. Then we set the font weight to bold to really make it stand out. The color? Pure white, perfect contrast against our dark background. Wrap the text with a widget called Material. Now, set its color to colors.transparent. Let's add a subtle shadow to our text to give it more depth. We'll use a soft blur, a dark shadow color, and slightly offset it to create a natural-looking effect. Set the blur radius to 15, use black for the shadow color, and apply an offset of 3 on the x-axis and 3 on the y-axis. The height controls the spacing between lines of text. Setting it to 1.1 slightly increases the line height, making the text more readable and visually balanced, especially since it spans multiple lines. Let's add a size box to give a certain amount of vertical space. Now, the text widget displays the phrase, "The ultimate battle of X and O." Now, we will style this text using text style. We set the font size to 16 to keep it smaller and subtle. The color is white with some transparency for a softer look. And the text is italicized to add a stylish touch. Let's create a new folder called Model. It will store Dart classes that define the structure of our data. This keeps our project clean and well organized. Let's create a folder named Widgets. This will contain all the reusable UI components used across the app. It helps keep the code modular and easy to manage. Now create a new file in it called menu_button.dart. We start by importing the material.dart package, which gives us access to all the core Flutter widgets. Then, we define a reusable widget named Build Menu Button. It takes several parameters: the build context, a text label, an icon, a color, and a function to run when the button is pressed. This function returns a custom button that we can use throughout the app. We start by returning a padding widget. This adds vertical spacing around the button, specifically 12 pixels on the top and bottom, to prevent it from feeling cramped against other elements. Inside the padding, we place a sized box. This allows us to control the width of the button precisely. We use Media Query to make the button span 80% of the screen's width, ensuring it looks consistent across different device sizes. Next comes the elevated button. This is the actual button widget that users will interact with. We apply custom styling using elevated button.styleFrom. First, we set the foreground color to white, which means the button's text or icon will appear in white. The background color is dynamically set using the color parameter passed to this widget, giving us flexibility to use different colors for different buttons. We then add internal padding using edge insets .symmetric, giving the button vertical padding of 18 and horizontal padding of 20. This makes the button easier to tap and visually more balanced. For the shape, we use a rounded rectangle border and give it a border radius of 20 pixels, which gives the button rounded corners and a modern, smooth look. We also set the elevation to 5, which lifts the button slightly above the surface, giving it a raised appearance. Finally, we add a shadow using shadow color. Here, we use black with 30% opacity. So the shadow looks subtle, but still provides a nice depth effect. We set the onPressed property to the onPressed function passed as a parameter. This means whenever the button is tapped, it will trigger the specific action we define when calling this widget. Now, inside the button, we use a row widget as the child. This lets us place multiple widgets, like an icon and text, side by side, horizontally. We set main axis alignment to main axis alignment.center to ensure that the icon and text are both centered within the button for a clean, balanced look. Inside the row, the first widget is an icon, where we use the icon passed as a parameter and set its size to 28, making it large enough to be clearly visible. Next, we add a size box with a width of 15 to create spacing between the icon and the text, so they don't appear too close together. Then comes the text widget, which displays the label passed as the text parameter. We apply a text style with a font size of 20 for clear readability, and a font weight of W600 to make the text bold and prominent, giving the button a strong and professional appearance. Now, let's call the build menu button function to create a menu option for player versus player mode. We pass the context as the first argument, which is required for navigation and layout. The second argument is the text label player versus player, which will appear on the button. Next, we pass an icon, icons.people_alt_rounded, to visually represent two players, matching the button's purpose. Then, we set the button's background color to colors.blue accent, which gives it a bright and attention-grabbing look. Finally, we define the onPressed function. Here, we use navigator.push to move to a new screen when the button is tapped. Specifically, we navigate to the player name input screen and pass the game mode.pvp as a constant. This sets the game mode to player versus player. Copy the same for player versus AI mode. Change the color to purple accent. We add a size box with a height of 30 to create some vertical spacing before the next widget. Next, we use a text button, a simple, flat button commonly used for secondary actions. The onPressed callback will be connected to a function called _show_about_dialog, which will display a dialog box when the button is tapped at present. We will pass empty function. Inside the button, we use a text widget that displays the label about game. We apply a text style to it, setting the color to white with reduced opacity, so it appears softer and less prominent than the main buttons. We also set the font size to 14 to keep it small and unobtrusive, suitable for a secondary option at the bottom of the screen. We define a private function named _show_about_dialog, which takes the build context as a parameter. This function will be called when the About Game button is tapped. Inside the function, we use Show Dialog to display a custom dialog box over the current screen. We pass in the context and define the dialog's content using the builder parameter. We return a dialog widget with its background color set to transparent. This removes the default white background, allowing us to fully customize the appearance. Inside the dialog, we use a container as the main content holder. It's wrapped with a box decoration to style the background. For the background, we apply a linear gradient, starting from the top center and ending at the bottom center. It blends from a deep purple color at the top to black at the bottom, creating a dramatic and sleek visual effect. Now pass the underscore show about dialog function here. We also give the container rounded corners using a border radius of 20, making the dialog look modern and smooth. Inside the container, we add padding using edge in sets.all 25 to give equal spacing on all sides and prevent the content from touching the edges. Then, we use a column to stack multiple widgets vertically. We set main axis size to main axis size.min, which ensures the column takes up only as much vertical space as needed for its content, making the dialog compact and well-fitted. The first child of the column is a text widget that displays the heading, About Ultimate Tic Tac Toe. We apply a text style to this heading, setting the font size to 22 for emphasis, making it bold for better visibility, and coloring it white so it stands out clearly against the dark gradient background. We insert a size box with a height of 15 to add vertical space below the heading. Next, we add a text widget that shows the description, a strategic twist on the classic game. Play against a friend or challenge the AI. We align the text to the center using text align, textalign.center, so it looks balanced and easy to read inside the dialog. Then, we apply a text style with a font size of 16 for good readability, and set the color to white with a bit of opacity, making the text appear slightly softer while still standing out on the dark background. We add a size box with a height of 20 to create some spacing below the description text. Next, we place an elevated button that will act as a close button for the dialog. The on-pressed callback is empty at present. Inside the elevated button, we use a text widget that simply says close. Its color is set to white, so it stands out clearly against the semi-transparent background. Now we set the onPressed property to navigator.pop context. This means when the button is tapped, it will close the current dialog and return to the previous screen. It's a simple way to dismiss pop-up dialogues in Flutter. We customize the button's appearance using elevated button.styleFrom. The background color is set to white with low opacity, giving it a transparent, glass-like look that blends well with the dark background. The button shape is rounded using a rounded rectangle border with a border radius of 15, making the corners smooth and clean. We add internal padding using edge insets.symmetric, 30 pixels horizontally and 12 vertically for a comfortable and balanced touch area. Create a new file called player_name_input_screen.dart. Let's use the STL shortcut to quickly generate the boilerplate for a stateless widget class. This is a handy shortcut in Flutter that creates the basic structure of a stateless class with the build method. Create a new class game_mode.dart. It has two values, PvP, which stands for player versus player, and PvAI, which means player versus AI. Using an enum helps us clearly manage different game modes in a clean and readable way. Add a final variable, mode of type game mode. Add a final variable, mode of type game mode. We begin by creating two text editing controller instances, _player1 controller and _player2 controller. These controllers help us manage and retrieve the text input from the name fields of player 1 and player 2. Next, we define a form key using global key form state. This key will be used to validate the form and manage its state. Then, we override the dispose method. This is called when the widget is removed from the widget tree. Inside it, we dispose both text controllers, _player1 controller and _player2 controller, to free up resources and prevent memory leaks. Finally, we call super.dispose to make sure the base class cleans up properly as well. Replace the placeholder with a scaffold. This provides the basic structure for our screen layout. Inside the body, add a container to design the background. Now, wrap this container with a gesture detector. This allows us to detect taps anywhere on the screen. Inside the onTap callback, we call focus_scope.off context.unfocus, which closes the keyboard when the user taps outside a text field. To style the background, we use a box decoration with a linear gradient. It blends from dark blue to black, starting from the top left and ending at the bottom right, creating a modern and immersive visual experience. Now, let's replace the empty callback with a function in the Build menu button inside the main screen code, like this. We use navigator.push to navigate to a new screen. Then, using material page route, we return the player name input screen. We also pass GameMode.pvp as an argument, so the screen knows the user selected player versus player mode. Now, let's replace the empty callback with a function in the Build menu button for the player versus AI button, like this. Here pass GameMode.pvai as an argument, so the screen knows the user selected player versus AI mode. Inside the scaffold, we use a center widget to align everything in the middle of the screen. Next, we place a single child scroll view to make sure the content stays scrollable, especially on smaller devices where the keyboard might cover input fields. We add padding all around using edge insets.all 20. Inside the scroll view, we add a form and assign it the _form key to manage form validation. Then we use a column to stack all the form elements vertically and align them to the center using main axis alignment.center. At the top of this column, we add a hero widget with the tag logo. This allows us to animate this element between screens that share the same tag. Inside the hero, we use a material widget with a transparent background. And finally display a text widget that says Enter Player Names. The text is styled to be bold, white, and large in size, making it clear and eye-catching. Let's define a custom widget called _build_player input field. This function takes in 3 required parameters: a text editing controller, a label string for the field, and an icon to visually represent the input type. Inside the function, we return a text form field. This widget will be used to accept player names as input. By defining it as a reusable method, we avoid writing the same input code multiple times and keep our codebase clean and maintainable. Inside the text form field, we first assign the controller to the one passed as a parameter. This helps us track and manage the user's input. Next, we add a validator function. It checks whether the input is either null or just empty spaces. If it is, we return an error message saying please enter a name. Otherwise, if the input is valid, we return null, which means no error. This ensures that the player must enter a name before continuing. Then we call _build_player input field to create an input field for player 1. We pass the _player 1 controller to manage the input. Set the label as player 1 X and add a person icon to visually indicate it for player details. After that, we check if the game mode is game mode.pvp, which means player versus player mode is selected. If that's true, we show one more input field for player 2, O. Before displaying it, we add a small vertical space of 20 pixels for proper spacing. This setup makes sure that the second input field appears only when it's needed, keeping the interface simple and dynamic based on the selected game mode. Now, let's style our input field using the decoration property of the text form field. We use input decoration to customize the look and feel. We start by setting the label text, which displays the hint above the input field, and we style it using label style to give it a soft white appearance. Next, we add a prefix icon to visually indicate the purpose of the field, like a person icon for player names, and give it the same white tint. To enhance visibility, we enable the filled property and set a light transparent background using fill color with low opacity white. This makes the input box stand out gently against the dark background. We also set the error style so any validation errors appear in white, keeping it readable and consistent with the rest of the UI. Then we define different border styles. Let's set the default border of the input field using outline input border. We set the border radius to 15 pixels to give the corners a smooth, rounded look. The border side is set to none, which means the border is invisible by default. The focused border appears when the user taps the field, adding a thin white outline. The error border adds a solid black outline when validation fails. And the focused error border does the same while the field is still focused. All of this together gives the text form field a modern and clean appearance, while also keeping user interactions clear and visually appealing. When the input field has a validation error, we use error border to show a black outline with a width of 1 pixel. The border corners remain rounded with a radius of 15 pixels to match the overall style. Similarly, when the field is both focused and has an error, focused error border applies the same black outline. This helps clearly indicate to the user that there's an error while maintaining consistent styling. First, we add a size box with a height of 40 pixels to create vertical spacing above the button. Then, we create another size box to set the button's width to 70% of the device's screen width, and a fixed height of 55 pixels for a nice, tall button shape. Inside it, we place an elevated button. The on-pressed callback is currently empty, meaning the button doesn't perform any action yet. We style the button using elevated button.style from, setting its background color to blue accent, which makes the button visually pop with a vibrant blue tone. To soften the edges, we give it rounded corners with a 15-pixel radius using rounded rectangle border. This button is designed to be wide, tall, and visually appealing with smooth rounded corners. Inside the button, we add a text widget displaying the label Start Game. We style this text with a font size of 18 for clear readability. Make it bold to give it emphasis and importance, and set the color to white to contrast sharply against the blue button background. This ensures the button label is easy to see and visually stands out. Create a new file called audio_manager.dart. Now create an assets folder with sounds folder in it. I have pasted the audio in this folder, and you all can get these resources in the description box for free. Search Audio Player Flutter in search engine, click the link and copy this package. Paste the copied package here in pubspec.yaml file. Select pub upgrade or directly run pubget. Select pub upgrade or directly run pubget. We begin by creating a class named Audio Manager to handle all the audio-related features in our game. Inside it, we define a private instance of Audio Player, which will be used to play sound effects and background music. Here there's a problem while importing the package we installed in pubspec.yaml file. Let's see. Sometimes our current Flutter package doesn't support latest package, so we lower it as we done it here. Now again run pubget. Now it gets successfully imported. We define two Boolean variables, underscore is sound on is set to true, which means sound effects are enabled by default. And underscore is music on is set to false, so background music starts off as disabled. To access these values safely from outside the class, we use toGetter methods. Is sound on and is music on? These provide read-only access to the current audio settings, while keeping the actual variables private and protected from direct modification. We define an asynchronous method called init that returns a future void. Inside it, we use await to set the audio player's release mode to loop. This means the audio will continuously repeat once it finishes playing. A perfect setting for background music or looping sound effects. We create a method named playSound, which takes a sound file name as a parameter. It's marked as async because we'll be performing asynchronous operations inside it. First, we check if sound is turned off using underscore is sound on. If it's false, we simply return and don't play anything. If sound is enabled, we use a try block to safely attempt to play the audio. We call underscore audio player.play and pass it the path to the audio file located in the sounds folder. We dynamically construct the full file name using the string passed into the function. Finally, if any error occurs during playback, it's caught in the catch block. So the app won't crash if the audio fails to load or play. We define a method called toggle sound. This simply switches the underscore is sound on Boolean to its opposite value. If sound is currently on, it turns off. If it's off, it turns on. Next, we have toggle music, which works the same way for background music. We flip the value of underscore is music on, and based on the new value, we take action. If music is now turned on, we call play background music to start playing it. Otherwise, if the user turns it off, we stop the audio using underscore audio player dot stop. This keeps the background music in sync with the user's toggle setting. We define an asynchronous method called play background music. It's designed to play the background music in our app. First, we check if music is turned off by evaluating underscore is music on. If it's false, we simply return early and skip playback. If music is enabled, we enter a try block and attempt to play the background track. We use underscore audio player dot play and load the file from the sounds directory, specifically background.mp3. If anything goes wrong during playback, such as the file not being found, the error is caught in the catch block to prevent the app from crashing. We define a dispose method to clean up the audio resources when they're no longer needed. Inside it, we first stop any currently playing audio using underscore audio player dot stop. Then, we call underscore audio player dot dispose to release the resources tied to the audio player. We mark the method as async because both stop and dispose are asynchronous operations. This ensures efficient memory management and prevents potential memory leaks in the app. Create a new file called Tic Tac Toe screen.dart. Let's create a stateful widget using the shorthand STF. This gives us the full structure we need for a widget that maintains state. Now, we name our class Tic Tac Toe screen, and it extends stateful widget. Inside the class, we define 3 required parameters. The first is mode, which will decide if the game is player versus player or player versus AI. The next two are player 1 name and player 2 name, which hold the names entered by the users. We pass these values through the constructor using the required keyword to make sure they are always provided. Create a new file game underscore state.dart. And now we enter the heart of the game logic, the game state class. This class is responsible for holding all the crucial data that defines the current state of our tic-tac-toe game. First, we declare a 2-dimensional list called board. This is a 3x3 grid that will store the values of each cell, whether it's an X, an O, or still empty. Next, we have the current player variable. This keeps track of whose turn it is at the moment, either player X or player O. Following that is game over, a Boolean flag that becomes true when the game ends, whether by a win or a draw. Then comes winner, a string that will store the result once the game concludes, either X, O, or an empty string if no winner yet. We also keep a record of scores. Player score and player score track the number of games each player has won, while draws records how many matches have ended without a winner. Finally, is thinking is a flag used mainly for AI gameplay. When set to true, it tells us the AI is currently calculating its move. All these variables are initialized through the constructor. Each field is marked as required, ensuring that no part of the game state is left undefined when an instance is created. In short, the game state class acts as a single source of truth for the current situation of the game, allowing for clean and consistent management of gameplay data. We start by defining the initial state of the game using a named constructor called initial. The board is initialized as a 3x3 grid with every cell starting off empty, setting the stage for a new round. The current player is set to X, meaning player X gets the first move. The game over flag is set to false, indicating that the game is still in progress. The winner field is left blank, since no one has won yet. Scores are reset. Both player X and player O start at 0. We also initialize the draw counter to 0, since no games have ended in a tie. And finally, is thinking is set to false, since no background AI move is currently being calculated. Next, we define the copy with method, a powerful tool for updating the game state. It allows us to create a new instance of game state by selectively modifying only the values we need. If a new board is provided, we use it. Otherwise, we keep the existing one. Same goes for the current player. We update it only if a new value is passed. We apply the same logic to the game over flag, the winner, and the score counters. Each property checks if a new value is available. If not, it holds onto its current value. This makes the game state both flexible and efficient, perfect for managing dynamic changes during gameplay. Inside the copy with method, we return a new instance of game state. First, we check if a new board is provided. If yes, we use it. If not, we stick with the existing board. Then we do the same for the current player. If a new value is passed, we update it, otherwise we keep the current one. Next, we handle the game over flag, switching it only if a new value is given. The winner field follows, updated only when needed. Then we move on to the score for player X. It's updated if a new value is passed in. Player O's score is handled the same way, replaced only when explicitly changed. The draws count is also updated conditionally, using the new value if one is provided. And finally, we check the is thinking flag. It's updated only when a new value is passed in. This entire approach ensures we only change what we need, keeping the rest of the game state intact. Create a new file called game_logic.dart. We begin by defining a class named GameLogic, which will contain the core game rules. Inside this class, there is a method called checkWinner. This method's job is to determine if a player has won the game after making a move. The method accepts 4 parameters: the current game board, represented as a two-dimensional list of strings, the row and column indices where the last move was made, and the player's symbol, such as X or O. First, the method checks the entire row where the move was placed. It compares each cell in that row to see if they all belong to the same player. If every cell in that row matches the player's symbol, it immediately returns true, indicating the player has won by completing a row. If the row check doesn't find a winner, it moves on to check the column of the last move. Similarly, it verifies if all the cells in that column contain the player's symbol. If they do, the method returns true, signaling a column victory. Next, the method checks the diagonals, but only if the move was made on a diagonal cell, because diagonal wins can only happen there. It first checks the main diagonal that runs from the top left to the bottom right. If the last move lies on this diagonal, the method compares all 3 diagonal cells to the player's symbol. If they all match, it returns true, meaning the player won diagonally. Then, it checks the anti-diagonal, which runs from the top right to the bottom left. If the move was placed on this diagonal, the method checks all 3 cells along this path. If they all belong to the player, it returns true. If none of these conditions are met, meaning no full row, column, or diagonal is controlled by the player, the method returns false, indicating there is no winner yet and the game should continue. This method is called isBoardFull, and its purpose is to check if the entire game board is completely filled with moves, meaning there are no empty spaces left. It takes the game board as input, which is a two-dimensional list of strings representing each cell. We use a nested loop to go through every row in the board one by one. Inside each row, we then loop through every individual cell. For each cell, we check if it is empty, meaning no player has made a move there yet. If we find even a single empty cell, the method immediately returns false, because the board is not yet full. If the loop's complete without finding any empty cells, that means every spot on the board is filled. In that case, the method returns true, indicating the board is full and no further moves can be made. This check is important to detect if the game has ended in a draw when no player has won but no moves are left either. This method is called getIMove, and it's designed to decide the best move for the AI player on the current game board. First, we create an empty list called empty cells, which will store all the available empty spots on the board where the AI can make a move. Then, we use two nested loops to scan the entire 3x3 board by row and column. For each cell, we check if it is empty, meaning no player has placed a move there yet. If a cell is empty, we add its coordinates, that is, the row and column indices, to the empty cells list. After checking all cells, if no empty cells are found, meaning the board is full, we return null because no moves are possible. This method is called _copyBoard, and its purpose is to create a deep copy of the current game board. It takes the existing board, which is a list of lists of strings, and copies it so that changes to the new board won't affect the original. We use the map function to go through each row in the board. For each row, we create a new list of strings by copying the contents of that row. We convert the mapped rows back into a list, resulting in a completely new two-dimensional list structure. Next, we loop through each empty cell in the empty cells list to check if placing an O, the AI symbol, there would result in an immediate win. For each candidate cell, we first create a temporary copy of the board to simulate the move without affecting the actual game state. Then, we place the AI's symbol O in that temporary board at the candidate cell's position. We use the check winner method to see if this move would win the game for the AI. If yes, we immediately return that cell as the best move, since winning right now is the highest priority. Now, this part is checking to block the opponent's potential winning move. We loop through all the empty cells on the board. For each empty cell, we create a temporary copy of the board using the _copyBoard method. Then, we simulate placing the opponent's move, represented by X, in that empty cell. After placing X, we check if this move would make the opponent win by calling the check winner method. If it detects that the opponent would win by placing a mark here, we immediately return that cell's position. This way, the AI can block the opponent from winning on their next turn. Now we move on to the AI strategy for selecting the best move when no immediate win or block is needed. First up, we check if the center of the board is available. That's the cell at position 1, 1. If it's empty, we return that cell. Why? Because the center is a strong strategic position in Tic Tac Toe. Next, if the center isn't available, the AI looks to take one of the corners. We define a list of all 4 corners, top left, top right, bottom left, and bottom right. Then, we loop through each corner. If we find a corner that's empty, we return it immediately. Corners help form multiple winning paths, so it's always a smart early move. Finally, if neither the center nor the corners are free, we fall back to just picking the first available empty cell. This ensures the AI always makes a move, even if no strategic positions are left. And with that, the AI's decision-making logic is complete. create a new file called gameboard.dart. We start with a gameboard class. It extends stateless widget, which means it doesn't manage any internal state. It takes two inputs. First, a 2D list called board that represents the Tic Tac Toe grid. Second, a function on cell tapped that runs when a user taps a cell. The constructor uses const and requires both board and on cell tapped, making sure this widget always knows what to display and how to react. Now, we replace the placeholder with a container widget. This container adds padding all around 10 pixels of breathing room inside. Next, we add decoration to style the container. We give it rounded corners using border radius dot circular 20, which softens the edges for a modern, clean look. We then add a background color, white, but with reduced opacity, so it appears slightly transparent, blending smoothly with the background. Finally, we draw a border around it, again using white at 20% opacity, with a subtle 1 pixel width, just enough to give it structure without being too bold. And that completes the visual styling of our container. We begin with a column widget. This stacks its children vertically. Inside it, we use a loop. For each index I from 0 to 2, we create a row widget. This places the game cells side by side for that row. We center everything using main axis alignment.center, so it all stays aligned neatly in the middle. Now inside each row, we run another loop for index j from 0 to 2. For each cell, we place a gesture detector. This allows us to detect user taps on each grid cell. When a cell is tapped, we call the onCellTapped function and pass in the current row and column. Inside this gesture detector, we build a container with fixed width and height 80 by 80 pixels. We add a small margin of 5 pixels around each cell to separate them. The background color of each cell depends on its value. If the cell is empty, we give it a subtle white shade with low opacity. If the cell contains an X, we apply a red tint. If it has an O, we go with blue. We round the corners using border radius dot circular 15 and add a border with color matching the cell content, white, red, or blue, and set it to 2 pixels thick. At the center of each cell, we place a text widget displaying the content either X, O, or empty. We style this text with a large font size of 40, bold weight, and color matching its respective symbol, red for X and blue for O. And that completes our dynamic 3x3 game grid, fully styled, tappable, and responsive to game state. Create a new file called confetti_effect.dart. Search for the Google Confetti package on pub.dev. Once you find it, copy the package name and version. Then, just like you did with the audio player package, paste it into the pubspec.yaml file under dependencies. We begin by creating a stateless widget called confetti effect, which means it doesn't hold any internal state and relies solely on the data passed to it. We pass in a required parameter, the confetti controller. This controller will handle when the confetti animation should start or stop. Now inside the build method, we return the main component of this widget, the confetti widget. This comes from the confetti package we just installed. We hook the confetti controller to our controller so that it can trigger the animation. Next, we set blast directionality to explosive, which means confetti will burst out in all directions, full celebration mode. We then specify number of particles as 50. This controls how many confetti pieces will appear at once. Gravity is set to 0.1, so the confetti gently falls down the screen. Then, we add a colorful mix: green, blue, pink, orange, and purple. These are the colors of the confetti pieces. Finally, we set should loop to false. This means the confetti will only play once per trigger instead of looping continuously. And that's your reusable confetti effect widget, perfect for a celebration when a player wins the game. Alright, let's dive into how we handle starting the game when the user taps the Start Game button. We begin with the _start game function. First up, we check if the form is valid. If it's not, we simply return and stop the function right there. That means both player names must be filled in correctly before we move forward. Next, we use the navigator.push method. This helps us move from the current screen to the actual game screen. Inside material page route, we define which screen we want to show. In this case, it's the Tic Tac Toe screen. We then pass the selected game mode to the screen using widget.mode. For the player names, player 1 name is taken directly from the first text controller, and we trim it to remove any accidental spaces. For player 2 name, we check what game mode was selected. If it's player versus player, we fetch the second name from the second controller. But if the user chose to play against the computer, we automatically set player 2's name to AI. And that's it. The game starts, and the players are taken to the tic-tac-toe battlefield. We replace this empty function with the method _start game. So now when the user presses the button, the _start game function will be called. Now let's build tic-tac-toe screen. We start by declaring _game state using late, which means it will be initialized later. Then we create _game logic to handle all the game rules like checking for a winner. Next, _audio manager is initialized to manage all sound effects and music. Lastly, _confetti controller is declared to trigger the confetti animation when there's a win. These are the core tools that run the game's logic, sound, and celebration effects. Let's override the init state function. This method is the first thing that runs when the widget is inserted into the widget tree, perfect for setting up the initial state of our game. Inside it, first, we call super.initState to make sure everything from the parent class is initialized properly. Then, we initialize our game state using a predefined initial setup. This sets up an empty game board, sets the starting player to X, and resets all scores and flags. Next, we create our confetti controller and set it to last for 3 seconds. This will be used to celebrate the winner with a burst of colorful animation. We also initialize the audio manager here. That sets up background music and sound effects so they're ready when needed. Lastly, there's a special condition. If the game mode is player versus AI and the AI is supposed to go first, we delay for half a second and then automatically trigger the AI's move. This simulates a natural pause before the AI responds. So this setup ensures everything is ready before the game begins, from visuals to audio and logic. Replace the placeholder with a scaffold widget to structure the basic visual layout of the screen. Inside the scaffold, return a stack, which allows us to layer multiple widgets on top of each other. Now, at the bottom layer of the stack, we place a container. This container is responsible for painting the background of our screen. We give it a beautiful gradient using box decoration. The gradient starts from the top left corner and ends at the bottom right. It transitions smoothly between two colors, dark blue from the colors .blue shade, 900 ND black, giving it a rich, immersive feel suitable for a game environment. This layered setup sets the stage for the rest of the game UI to be built on top. Now inside that container, we wrap everything with a safe area to make sure our content stays within the visible screen area and doesn't clash with things like the status bar or the notch. Next, we use a column to arrange our widgets vertically on the screen. At the top of this column, we add a padding widget with some spacing around it, giving a neat margin of 4 pixels. Inside that padding, we insert a row to arrange items horizontally, and we set the main axis alignment to space between, so the children will sit at the far left and far right of the screen. Now, on the left side of this row, we add an icon button. This displays a back arrow icon, styled in white with a size of 30. When this button is tapped, it triggers the navigator.of context.pop until route is equal to route.isFirst function. This means it will take the user all the way back to the very first screen in the navigation stack, essentially a full back navigation to the home screen. Next, we place another row to the right side, which holds a set of icon buttons for sound and music controls. Inside this row, we begin with an icon button. This icon dynamically switches between a volume up and volume of icon depending on whether the sound is currently enabled. The condition underscore audio manager dot is sound on checks the current state. If sound is on, it shows the volume up icon. If it's off, it switches to the mute icon. The icon color is set to white, and the size is a noticeable 30 pixels, making it easy to tap. Right now, the onPressed function is empty, but this is where we would typically add the logic to toggle the sound on or off when the user taps the icon. Next, we add another icon button right beside the sound button. This one controls the music and displays either a music note icon or a music of icon based on whether music is playing. If underscore audio manager dot is music on is true, it shows the music note icon, indicating music is active. If false, it switches to the music of icon, signaling music is paused or stopped. Like before, the icon is white and sized at 30 pixels for clarity and easy interaction. The onPressed function here is also empty for now, but is meant to toggle the music state when tapped by the user. Here comes the text widget. This widget is responsible for displaying who the players are in the game. We begin with a conditional check. If the selected game mode is player versus player, then we show player 1's name followed by versus and player 2's name. Otherwise, we show player 1's name followed by versus AI, indicating that the second player is an artificial opponent. Now for the styling part. The text size is set to 24. The font is made bold to give it more visual weight. And the color is set to white, so it stands out clearly against the dark background. This heading gives players instant clarity about the matchup. We start with a padding widget, adding 12 pixels of space all around the child. This ensures our score section doesn't feel cramped. Inside the padding, we place a row, which lays out its children horizontally. we set the main axis alignment to space evenly, so the 3 score widgets are spaced out evenly across the screen. A widget called _build player score, which takes 2 inputs, the player's name and their score. Inside, we return a column widget. This allows us to stack the player's name and their score one above the other. First inside this column is a container, which wraps around the player's name. This container has some padding on the left and right, as well as top and bottom, making the name feel comfortably spaced inside. For the styling, the container uses a semi-transparent white background, giving it a soft glow over the dark theme. Rounded corners are applied using a border radius, giving it that modern, card-like appearance, which is visually appealing. And that's the setup for displaying the player's name in a well-styled box. Now for the children. First, we call _build player score, passing in player 1's name and their current score. This displays player X's score clearly. The container is styled with a semi-transparent white background and softly rounded corners, giving it a smooth, modern card-like appearance. Inside this container, we display the label draws using a text widget. The font size is set to 16, the text is bold and colored white. This ensures it's clearly visible. Below that, we add a size box with 5 pixels of vertical space to create some gap between the label and the actual number. Finally, we display the total number of draws using another text widget. The number is pulled dynamically from the game state. It's styled with a larger font size, 24, to make it stand out, and it's also bold and white. Altogether, this widget cleanly and clearly highlights the number of draw matches that have occurred so far. We define a widget called _build draw score. This is used to display the number of draws in the game. Inside it, we start with a column widget. This stacks all the child widgets vertically. The first child is a container, which holds the label draws. This container has some padding around the text, both horizontally and vertically, giving it breathing room and making the label look clean. Its background color is set to white with a very light opacity, making it slightly visible on the dark background without being too bold. The container's corners are rounded using a border radius of 10. This softens the edges and gives a more modern UI look. Inside this container, we place a text widget with the word draws. This is styled with a font size of 16, colored white for visibility, and bold to make it stand out. Just below the container, we insert a sized box with a height of 5. This adds vertical space between the label and the actual draw count, keeping the layout neat and readable. Call the function here. Inside the container, we display the player's name using a text widget. The text is styled with a font size of 16, a white color to contrast nicely with the dark background, and it's bold, giving the name some extra emphasis on the scoreboard. Now below the label, we display the actual number of draws. We use a text widget to convert the draw count from the game state into a string and show it on the screen. The styling here is slightly more prominent. The font size is 24, making the number stand out. The color is white, keeping it consistent with the overall theme. And it's set to bold, giving it visual weight so players can quickly recognize the score. This clean and simple design helps players immediately see how many games have ended in a draw. Here we are missing something, and it is we haven't called the build player score method when we are in player versus player or AI mode. Here, we build the score display for the second player. We check the game mode. If it's player versus player, we show the actual name of player 2. Otherwise, if it's player versus AI mode, we simply display AI as the opponent. We pass this name along with player O's current score from the game state to the underscore build player score method. This ensures the score panel updates dynamically based on the game mode and current scores. Let's override the dispose method to clean up resources when this widget is removed. First, we call dispose on the audio manager to release any audio-related resources and avoid memory leaks. Next, we dispose of the confetti controller, stopping any active animations and freeing its resources. Finally, we call the superclass's dispose method to ensure any additional cleanup is properly handled. This ensures the app remains efficient and doesn't hold onto unused resources unnecessarily. We begin by defining the function that handles making a move on the game board. First, we check if the selected cell is already occupied to prevent overwriting a move. We also verify if the game has already ended or if the AI is currently processing its move. If any of these conditions are true, we simply return and do nothing, ensuring the game state remains consistent. If the move is valid, we proceed to update the game state, which triggers the user interface to refresh. To do this safely, we create a new copy of the current board to avoid directly mutating the existing state. Then, we copy the specific row we are updating, keeping immutability intact. Next, we assign the current player's symbol, either X or O, to the targeted cell on this new board. With the board updated, the game state now reflects this move. Right after, we play a sound effect that matches the current player's action, a cross sound for X and a circle sound for O. Finally, we check whether this move leads to a winning condition by analyzing the board, the position just played, and the current player. If a win is detected, the game will respond accordingly to end or celebrate the match. This flow ensures smooth gameplay and keeps all state changes clear and controlled. Let's complete a synchronous method to handle the AI making its move in the game. First, we check if the game is already over. If yes, we simply return and do nothing to avoid unnecessary processing. Next, we update the game state to indicate that the AI is thinking, which can trigger a loading or thinking animation in the UI. We then pause for half a second, simulating the AI's thinking time to make the gameplay feel more natural. After this pause, we call the game logic to get the AI's best possible move based on the current board. If the AI finds no valid moves, we update the state to stop, showing the thinking indicator, and exit the method. If a move is available, we update the game board by placing the AI's marker, typically an O, in the chosen cell. We also update the state to stop the thinking indicator, signaling that the AI's turn is complete. Finally, we play a sound effect to provide audio feedback that the AI has made its move. Now we update the game state inside a set state call to reflect the AI's move. First, we create a new version of the board by copying the existing one. Then we access the specific row the AI wants to play on and copy that row as well. Within that row, we place the AI's symbol, which is O, into the selected cell. This ensures the game board reflects the AI's move without mutating the original state directly. We also set is thinking to false to indicate that the AI has completed its move. Finally, we play that circle sound to give feedback that the AI placed its symbol, making the interaction feel more responsive and engaging. Let's define a new method called _handle_win. Inside this method, we use setState to update the game state when a player wins. We first mark the game as over by setting game over to true. Next, we assign the current player as the winner. Then we update the scores. If the current player is X, we increment player X's score by 1. Otherwise, if the current player is O, we increment player O's score instead. This ensures only the winning player's score is increased. After updating the game state, we play the winning sound effect using the audio manager to provide a rewarding sound cue. And finally, we trigger the confetti animation to celebrate the victory visually on screen. This method wraps up everything we need to handle a win, updating the UI, scores, and triggering feedback for the player. Now let's create a method called _handleDraw, which will be triggered when the game ends in a draw. Inside it, we call setState to update the UI and internal game state. First, we mark the game as over by setting game over to true. Then, we assign the winner as draw to reflect that no player has won this round. We also increment the draw counter by 1. This helps track how many games have ended without a winner. Once the game state is updated, we use the audio manager to play a sound named fall, giving the players audio feedback that the match ended in a draw. This method neatly wraps up everything needed when no one wins, a clean state update and subtle audio cue to inform the players. Now let's define the _switch player method. This function is responsible for switching turns between players after each move. Inside the set state, we update the game state to reflect the new current player. It checks if the current player is X. If yes, it switches to O. If the current player is O, it switches back to X. This ensures that the game continues in turn-based fashion, moving control from one player to the other. Let's define the _reset game method. This function is used to start a fresh round of the game. We begin with a set state call to update the game's UI and state variables. Inside, we use the copy with method to reset key values in _game state. First, the board is regenerated as a new 3x3 grid filled with empty strings, clearing any previous moves. The current player is reset to X, meaning player X gets the first move again. We mark game over as false to indicate the game has resumed. The winner field is cleared to an empty string, since there's no winner yet. We also make sure its thinking is false, stopping any pending AI actions. Below that, we preserve the existing scores, player X score, player O score, and draws, so the match history is intact. Next, we check if the current mode is player versus AI and the AI is supposed to start. If so, we delay for 500 milliseconds, just like before, and then call _make AI move to let the AI take its turn. This ensures that the game resets properly with all logic and visuals refreshed for the next round. Let's create two helper methods to control the audio settings, _toggle sound and _toggle music. Starting with _toggle sound. Inside this method, we call _audio manager.toggle sound. This switches the game sound between on and off, like toggling a mute button. Then we call set state to trigger a rebuild of the UI. This ensures the sound icon updates immediately based on the new setting. Now moving to _toggle music. Just like before, we call _audio manager.toggle music. This will start or stop the background music. Again, we follow that with set state to reflect the change visually in the UI. These methods help keep the audio interactions smooth and user-friendly during gameplay. After the AI makes a move, we check if that move results in a win. We use _gamelogic.checkWinner, passing the current board, row, and column of the move, and O as the player. If it's a winning move, we call _handleWin. This will update the game state to reflect the win. But if the board is completely filled and there's no winner, then _gamelogic. is board full returns true. In that case, we trigger a draw by calling _handleDraw. Otherwise, if neither of those conditions are met, it means the game continues. So we switch the player turn by calling _switchPlayer. Now we wrap our content in an expanded widget, which ensures this section takes up all available space in the remaining layout. Inside it, we use a center widget to align the contents right in the middle. Then, we build a column, aligning all elements vertically. We center everything using main-axis alignment.center, so our content sits right in the middle of the screen. The first widget in the column is a text widget that displays whose turn it is. If the current player is X, we show player 1's name followed by S turn, X. Otherwise, if the game mode is player versus player, we display player 2's name and S turn, O. And if it's player versus AI mode, we simply show AI's turn, O. The style of the text is slightly translucent white, with a font size of 18. Next, we add some vertical spacing using a size box with height 20. Below that, we place the game board widget. This renders the Tic Tac Toe grid. We pass the current game board to it. And we also provide the _make move method, which will handle what happens when the user taps a cell. This entire section keeps the game interactive and responsive, showing the current turn and rendering the board neatly centered. We check if the game is over using _gamestate.gameOver. If it's true, we display the game result UI using a conditional spread operator. We begin with a padding widget that wraps the content with 16 pixels of space on all sides. Inside it, we use a column to stack the result content vertically. The first widget is a container, which acts like a stylish box for the result. This container has horizontal padding of 30 and vertical padding of 15, giving the text inside enough breathing room. The background color is set to blue accent, making it visually pop. We then round the corners using border radius.circular 30, giving it a pill-shaped look. Now let's add a shadow effect to our result box using box shadow. Inside the list, we use a box shadow to style how the shadow looks. we set the shadow color to blue accent, but we reduce its intensity by applying 40% opacity. This keeps it soft and subtle. Next, we give it a blur radius of 10. This makes the shadow appear smooth and diffused. The spread radius is set to 2, which makes the shadow slightly larger than the container itself, adding some emphasis. Finally, we offset the shadow 5 pixels downward, using offset 0, 5. This gives the effect that the box is gently floating above the screen. Alright, now let's drop in the text widget that shows who won the game. Okay, first, I'm checking if the winner is draw. So right here, yeah, if it's a draw, I'm displaying it's a draw pretty straightforward. Now, if it's not a draw, I move on and check if the winner is X. And since player 1 always plays as X, I'm showing a message like Aman wins. But wait, it's dynamic. So I'm pulling the actual player name from widget.pl air1 name, makes it more personal. Cool. Now if it's not X, that means O won the game. Here's the fun part. I'm checking if the game mode is PvP, player versus player. And if that's true, I'm showing player 2's name followed by wins. Otherwise, yep, you guessed it, it's the AI. So I just show AI wins. Nice and simple. Let's add some styling to this now. Font size? I'm going with 24, so it's nice and readable. Font weight is bold, gives it that punch. And color, solid white, to make it pop against the darker background. Perfect. That wraps up our winner text with logic that's clean, dynamic, and visually sharp. Alright, next up, we're giving players the option to play again. I'm starting with a little vertical spacing, size box with a height of 2, just to create some breathing room above the button. Now dropping in the elevated button. This is the main action button the user taps to restart the game. For the on pressed, I'm linking it to _reset game, our reset function that clears the board and gets things ready for a new round. Add an underscore to make it private. Inside the button's child, we are placing a text widget. This is what the user will see and tap. The label says play again, clear, concise, and action-oriented. It tells the user exactly what to expect. Now on to styling. We are setting the font size to 18. That's a good medium size, large enough to be readable and important, but not overwhelming. Next, we choose the color. I'm using colors.blue.shade 900, a deep, rich blue that stands out beautifully on the white background of the button. And finally, I'm making the font bold just to give the button label that extra emphasis and visual weight. This combination of size, color, and weight makes the button feel interactive, clear, and consistent with the overall theme. We begin with the style, property, and we're using elevated button.styleFrom to customize how our button looks. First up, background color, colors.white. We are setting the button's background to white. This gives it a clean and minimal look, which will help the blue text stand out. Then we've got padding. We use edgeinsets.sy metric, giving 2 pixels of vertical padding and 40 pixels horizontally. This makes the button nicely wide, giving the text breathing room on both sides without making it too tall. And finally, the shape. We use rounded rectangle border, and set a border radius of 15 pixels. This gives the button those smooth, rounded corners, which feel modern and friendly, not sharp or boxy. So in short, we've created a button that looks clean, is well padded, and has a soft, approachable design, all with just a few lines of styling. Add size box of height 5. And now, we're adding a fun visual element right here. We start with the confetti effect, which takes in our underscore confetti controller. This triggers a burst of confetti whenever a player wins, giving that satisfying "you did it" moment. Next, we add a conditional check with if underscore game state dot is thinking. This means if the AI or the other player is currently deciding a move, we want to show a loading indicator. So inside this block, we center everything using the center widget. Then, inside a column, we align everything to the center vertically using main axis alignment dot center. First in line, we've got a circular progress indicator. It's set to white using always stopped animation, so it matches our overall theme and stands out on a dark background. Right below that, we leave a little space with size box, height 20, just to give the layout some breathing room. And finally, we add a text widget. Now here's the cool part. The message is dynamic. If we're in player versus player mode, it shows player to name is thinking. But if it's player versus AI, it says AI is thinking. This creates a natural pause in gameplay, giving the impression that the AI or opponent is actually making a move, which adds a subtle but important layer of realism to the experience. Now let's handle the outcome after move is made. First, we check if the current move results in a win. We call underscore game logic dot check winner and pass in the board the current row and column and the current player. If that returns true, we immediately trigger underscore handle win to celebrate the victory and wrap up the round. But what if there's no winner yet? Well, next we check if the board is full, meaning all cells are occupied and there's no more space left. If that's the case, it's a draw. So we call underscore handle draw to update the score and notify the players. Now, if neither of those conditions are true, that means the game continues. So we switch the current player by calling underscore switch player. Here comes the smart part. If the mode is player versus AI, and after switching, the current player turns out to be O, which is the AI. We want to delay the AI move just a little to simulate thinking. So we use future.delayed with a short delay of 300 milliseconds. And then we call underscore make AI move to let the AI take its turn. This whole flow keeps the game dynamic, checks for win and draw, and ensures smooth transitions, especially in AI mode. Everything is working perfectly now. We've updated the app's name and fixed some overflow issues. With these final touches, our app is complete. Let's fix the sound issue by correctly adding the import in our pubspec YAML file, which we had missed earlier. Run this command, Dart fix apply, to automatically apply the const keyword wherever needed and fix some issues. This is the final version of the app we've created. Through this project, our main focus was on understanding how to properly structure your Flutter codebase, and you've achieved that. Building the app was more of a practical exercise, helping you apply everything you've learned so far in Dart and Flutter. It's not just about finishing an app, it's about learning the process behind it. Thanks for watching this video. Do like, share, and subscribe to our channel and share on social media.